Hi everyone, this is Mrs. V Chan. Welcome to my Form 5 Business Lesson number 7. Today is 17th April 2020. Alright, so we will do some DSE question today for working capital management. So before we look at the question, so let's look at what is meaning of working capital. Working capital, the formula is equal to current assets minus current liability. Okay, and let's look at all the examples for current assets. For example, for current assets, we have inventory. Okay, and then we have accounts receivables. All right, and then we have cash. Okay, and then for current liability, we have accounts payable. Okay, and then in this chapter, we are going to deal with inventory management, accounts receivable management, cash management, but for DSE, so far we don't have any question related to accounts payable management. Okay, so today's lesson, we will follow this order. We will do inventory management first, and then we do accounts receivable management, and finally we have cash management. All right, so the first question for inventory management is about why we need to do inventory management and what is the purpose and what is the objective for doing that. So here, the question in 2019, we have this explain the main objective of inventory management, which is to make sure that the business, okay, keep enough level of inventory, but at the same time, to minimize the inventory costs. So this is the purpose for doing inventory management. Okay, but how can we minimize the inventory costs and then at the same time we have enough inventory to be sold to a customer? So we use that EOQ model, all right? And then in the question of 2014 here, so we have to draw a diagram to explain how we use EOQ model to make sure that we have minimized inventory costs and at the same time we keep enough or adequate level of inventory. All right, so here we have the diagram for EOQ model to show how it works. So the vertical axis, we have costs and in dollar sign, and the horizontal axis, we have order quantity in units. And here, the curve downward sloping, which is total ordering costs. And then we have the one upward sloping, which is total carrying costs. Okay, let's do some revision. What is the formula to calculate total ordering costs? So which is equal to F times D over Q. And what is meaning of F? Actually, F means order costs per unit. And then D is the annual demand for sales divided by quantity. That means if each time we order more quantity, therefore we have less number of orders, okay, and then we pay less ordering costs. So that's why the curve is downward sloping. All right. And then for total carrying costs, the formula, we have this C times Q over 2. And C here is carrying costs per unit, and then times the average inventory we have. Okay? Okay, so therefore, if you add up carrying costs and ordering costs, you will get total inventory costs, as we have these two components for this total carrying cost, and then you get this curve, all right? And then the thing here, when the inventory costs is at the lowest point, and which is also the intersection for total carrying costs and total ordering costs. So this is how we keep this as the optimum level for inventory. So we call that EOQ, which is equal to the formula is 2FD over C, and saying that we can minimize inventory costs at this point. So this is the idea for EOQ model. Okay, so in 2014, it's about the diagram to explain how EOQ model works. And then here we have another question in 2018. Now this time we have to describe in words. All right, so how does EOQ model to minimize the inventory costs? So here I have a typo, it should be model, all right? Okay, so explain EOQ model. So we start with the components for total inventory costs. So we have carrying costs, and then we have ordering costs. And after that, you give meaning for carrying costs, costs incurred on holding inventory. For example, we have this opportunity cost for money tied up in inventory and obsolescence, being outdated, all right? So ordering costs, meaning of ordering costs, you have costs incurred on placing and receiving an order. And here you also have example for ordering costs, like cost of communicating with supplier, transportation costs, etc. and etc. All right, so how do we get the minimum total inventory costs? So we start with this order size. So if we order more each time, then we need fewer orders. So therefore we have lower ordering costs. But however, if we order more, we will get more carrying costs. So you can see one is decreasing for ordering costs, but however for carrying costs, which is increasing. Therefore, to achieve the minimum point, these two ordering costs and carrying costs should compromise between each other. So therefore, at which point that they compromise with each other, so that will be the point when ordering costs is equal to carrying costs. So that's the total inventory costs is minimized. Okay, then we have a similar question in 2012. Part 1, explain how the use of EOQ model can reduce inventory costs. So the answer is at the EOQ, the total inventory cost consists of two components, R, ordering cost and carrying cost, S, minimal amount or possible quantities. All right, and after that, we need to do some calculation. So what should be the unit of EOQ related to this company, Plantin? Okay, so here is the question in 2012. So A2 here, using the EOQ model, calculates the optimal order quantity of oysters for this company. All right, so let's look at the formula. So the formula of EOQ is square root 2FD over C. All right, so F means the ordering cost per order, and then D is the annual demands. That means so the inventory we need to keep in order to sell to the customer, and then this is carrying cost per unit. Okay, and now we need to look at the question. And then in the question saying that the past sales records show that Plantin sold 400 dozens of oysters each week. Okay, and the oysters were ordered in dozens and the ordering costs was 800 per order. Now I get my ordering costs, and the symbol for that is F. All right, and the average carrying cost per dozen oysters was $16 per week. So in that case, if we have this everything per week, so that you don't need to worry about this is annual sales. Sometimes we can change that. This time it's not annual, which is per week. All right, so that I already have some of the information. Now I have my ordering costs, so which is $800 per order. So I have 800 here. Okay, and then each week I need to sell 400 dozen of oyster. So I have 400 here. And then divided by, okay, this is carrying cost. So holding cost is same as carrying cost, so that I have this $16 per week. All right, so this is how we do calculation for EOQ model. And now I can use my calculator. So 2 times 800 times 400 divided by 16, and then take square roots. So the answer is 200 dozens for oysters. All right, so after we have get this EOQ, which is 200 dozen, now I'm going to draw you this diagram to explain another way. All right, for this model. So this is 200 dozen, saying that this is the point that we have the lowest total inventory costs. Okay, so how much will be inventory costs? We can calculate actually. So that is at 200 dozen, total inventory costs consists of two components. One is total carrying costs. So here is the formula. Total carrying costs per unit times the quantity is 200 divided by 2 plus ordering cost given to us in the question is 800. 800 is the order cost per order times 400 is the sales, and then divided by 200 is the quantity. So therefore, if you use the calculator, you will get 3,200, okay, for the total inventory cost. So therefore, if I move horizontally to this point, so therefore the total cost when the level is 200 dozen, the total inventory cost will be 3,200. All right, however, if you go back to the question, you have this sentence. For this company, it is the restaurant's practice to order 600 dozen oysters each time to avoid shortages. So you can see the existing order quantity, 600 dozen, is good or no good. So we can do some calculation to prove that. Okay, so the lowest level is 200 dozen, but the existing order quantity for the business is 600 dozen. So here I have, for example, this is 600 dozens, and now I can calculate. So how much will be total inventory cost when it is at 600 dozen? Okay, so the first component carrying cost $16 times, I put 600 here, and then this is the ordering costs times 400 divided by 600. Okay, and let me use calculator. So 16 times 300 plus 800 times 4 divided by 6. Oh, so you can see the total inventory cost, which is 5,333, is much higher than the EOQ points when we order 200 dozen, which is only 3,200. So you can see in the existing case, if the firm orders 600 dozen, the total inventory cost here is 5,333, right? Which is much higher than the minimum points if the company order 200 dozen of oysters each time. Okay, so then we have another question to calculate EOQ, all right, which is 2016. Okay, so the information is here. So anyway, the formula is square root 2FD divided by C. Okay, so this is about, take beverage as an example. The past sales records show that our chain sold 500 boxes each month. So that means the demand here to be sold to the customer according to the past record is 500 boxes each month. We currently order 600 boxes. Now be careful. This is the situation being applied in this company. Whether it is good or no good, we don't know. So ignore this 600 boxes. And then the ordering cost is this. So here we have the ordering cost, so which is 5,625 per order, and the average holding cost per box, so here divided by 10. All right, so this is the formula we get EOQ. So if you use your calculator, you will get 750 boxes. Okay, now we come to 2016 and then A2. So based on the optimal order quantity calculated in A, states which inventory cost component contributes to the reduction in total inventory costs. Now let's look at the existing order quantity, which is 600 boxes. Is that right? Okay, but however, from our calculation, we get 750 boxes. Okay, let me use diagram to explain to you. So therefore, 600 boxes is on the left-hand side. So you can see when we have this on the left-hand side, so what is so high? This curve, all right, which is along the total ordering costs, which is much higher than the carrying costs. So that what makes us have higher total inventory costs, it is due to the total ordering cost is too high. Okay, so therefore the answer here, all right, states which inventory cost component contributes to the reduction in total inventory cost. So the answer will be ordering costs. Okay, and then now we need to explain using frequency. Okay, now here is some of the calculation. So what is the existing order quantity according to the question, which is each time the firm orders 600 boxes? But from our calculation, the best point should be 750 boxes. Okay, so how about the existing frequency? Okay, so that will be each year. So this is the chain. Okay, we'll sell 500 boxes each month. So we will get what is the annual sale. That will be 500 each month times 12, because 12 months in a year. So this is annual sale divided by each time we order 600 boxes each time, so that we can get the existing frequency. So 500 times 12 divided by 600, okay, which is 10 times. That means if we order 600 boxes each time, we need to order 10 times in a year. Okay, what about the best point, optimal point? Saying that this is the sales per month times a year divided by how many boxes would be the best according to calculation is 750. So divided by 750, so that I get 500 times 12 divided by 750. So that means it should be 8 times. So therefore, if we order more quantity each time from 600 to 750 boxes, so the order quantity going down from 10 times to 8 times. Okay, so this is the final explanation. So lower order frequency from 10 times to 8 times in a year, so that we can get and minimize the total inventory costs. All right, so that's all about the inventory management, and then I will make another video to show you accounts receivable management and then cash management. So thank you for watching my video. I'll see you next time. Bye bye.